Hello all, welcome back to the channel. In this session, let us see the third example on projection of straight lines. Straight away, the question is like this. A straight line AB has its end A 20 mm above the horizontal plane and 30 mm in front of the vertical plane. The other end B is 60 mm above HP and 45 mm in front of VP. The distance between end projector is 70 mm. So one of the important data as of now. Draw its projection, determine the true length and apparent inclinations. One by one, let us break down the datas. The first thing is I will take down the data towards the side of the paper. The straight line AB. Problem here is we do not know whether it is the apparent length or the true length. Forget about apparent length or true length, even the distance is also not given. Where is the point A? The dimension of the point A is 20 mm above the horizontal plane and 30 mm in front of the vertical plane. There is one more point B, even its dimensions are given. This is 60 mm above the horizontal plane and 45 mm in front of the vertical plane. Apart from all these data, one more data is given, that is distance between end projector. I will call it as DEP. So you can also call it as distance between end projector, all one and the same. So this data is these 70 mm. Please do remember, so this distance is now the horizontal distance. So all these four distance are the vertical distance. I mean, on the grid sheet, we take these four distance in a vertical direction, that is above and below the XY line, but we take this as the horizontal distance. If you can observe very clearly, no angle is given in the question. Either it's a true inclination or the apparent inclination, it is not given. So with this thing, we are supposed to determine the true length. Extremely important. True length has to be found out. The second one is the apparent inclination. So what is the true length means? That is nothing but A dash B1 dash distance or A B2 distance. What is the difference between two? Both are true length only, but the first true length is in the front view. The dashes indicates the front view. And the second true length is in the top view. Suppose if this is 67 mm means even this should be 67. Yeah, 0.1 mm, 2 mm, 0.1 centimeters here and there, the human error will be there. It is taken for consideration. Yes, what is the apparent inclination? Apparent inclination is nothing but alpha and beta. Once again, alpha in the front view, beta in the top view. Let us go step by step. The first step is to obtain the XY line. Try to keep the minimum thickness and immediately mark it as VP HP. This indicates the projection of straight lines is done in the first quadrant. Let us go for the first data. The dimensions of point A. It is 20 mm above the horizontal plane and 30 mm in front of the vertical plane. By this time, we should be knowing the fact that 20 mm above the horizontal plane is nothing but 20 mm above the XY line. 30 mm in front of the vertical plane means 30 mm below the XY line. I will immediately update the dimensions as well. Let us call this point as a point A dash and this is the point A. We have got two more locus here. So this end point indicates the locus line. Let us construct one locus line immediately. Locus line is a minimum thickness line. It is big line, small line, big line and small line. Let us follow the same procedure here also. So this is the locus line of point A in front view. Similarly, this is the locus line of point A in the top view. We have considered one set of data. One more set of data is given here. It is 60 mm above horizontal plane and 45 mm in front of vertical plane. I will consider 60 mm above the XY line, 45 mm in front of the vertical plane, that is below the XY line. This distance is measuring as 60 and this is 45. Please ensure it is taken from the XY line. So we have obtained two more locus. Let us update this locus now as locus line of point B in the front view. Similarly, locus line of point B in the top view. So we have taken down all the data. Left out data is the distance between the end projectors. 70 mm. As I told you, this has to be taken as the horizontal distance. What is distance between the end projector? A is one projector, B is one projector. So the distance between these two is 70 mm. We are having one projector here, A. So the B lies somewhere over here. It lies at a distance of 70 mm. That is what they are telling. Make use of scale here, 70 mm or 7 grids. So this is 0, 10, 20, 30, 40, 50, 60, 70. So for exactly at this point, draw one more line. So this horizontal distance is 70. We have taken all the data, only left out is the projections. Whenever we are having a true length has to be projected. The projected true length has to be now rotated. Thereby we are getting the apparent length and the apparent inclination. The question is true length is not given. If it is given, we could have projected and we could have obtained the apparent length. But if you carefully observe, we are supposed to find a true length only. So this itself is our target. So we are supposed to find out true length means indirectly it is telling that they have given the apparent length. Now let us rotate the apparent length. Let us project the apparent length. Thereby we are getting the true length, what we call the reverse engineering process. But the question is, where is the apparent length? Can you see A dash and the point here, the end projector distance? If the end projector distance is given means it is understood that apparent length is given. So now let us join these two with a good thickness. The point A lies here and there is a locus of point B here. Join these two with a thick line. I'm having the apparent length. I repeat, let us go for rotation. Let us make use of compass. Point A dash as the center, this point as the radius. Cut an arc. We are coming downwards actually. Now project the line. The arc end point lies here. Project the line till the last locus. So thereby I am getting the true length. Its minimum thickness. Let us follow the same procedure once again. I am having the apparent length at the top view. Point as the center, this is the radius. Rotate the apparent length. That has to be projected. So that intersects with the topmost locus. Join it to the initial point A dash as a true length with a minimum thickness. This would be the solution. But let us name all the corners and the dimension. A dash, what would be the end point here? As I told you, this is the B dash. The corresponding apparent length would be B dash. And the corresponding true length would be B1 dash. B1 dash is what we wanted to find out here. Similarly, this is the point AB. Corresponding true length would be B2. That is what we wanted to find out. B2, don't you think the projection is coming downwards here? So let us show the downward arrow mark. And here the projection goes in the upward direction. Let us show the upward arrow mark. Can you see here? B1 dash, in the front view it is B1 dash, but in the top view this should be B1. Similarly, B2 in the top view would be B2 dash in the front view. Let us update the angular dimensions now. The angles are too close to each other. I wanted the value of true inclination theta here and phi here. True inclination is not a part of solution. Okay, let us find it out. So let us find out the value of alpha. Yes, this is a part of the solution. This is the part of the solution beta. Let us check out one by one. Just a slight difference of 1 degree or 2 degree. So this is close to 29 degrees and this is close to 27 degrees. Similarly, phi and beta. So I will call the angle phi as 10 degree and the angle beta as 12 degree. I will place the protractor on the apparent length A dash and apparent length B dash. Let us draw true lines here. Now let us find out this distance. It's close to 80 mm. That is 8 centimeters. Similarly, I will show the apparent length in the top view as well. So this dimension is close to 73 mm. The last part left out is the true length dimension. Place your protractor on B1 dash on the true length line. On B1 dash mark 90 degree. On the true length line on A dash. So this is 90 degrees. So this is measuring close to 8.3 centimeters. So we can call it as 83 mm. Let us check what is the value of true length in the top view. Yes, it is 83 or 84. That means to say that what we have done till now, it is correct. Let us finalize the solution one by one. What is it we are supposed to find out? To determine the true length, A dash, B dash or AB2. So the true length is equal to A dash, B1 dash or AB2. It is measuring it as 83 mm. And apparent inclinations. Alpha is equal to beta is equal to. Alpha is showing as 29 degree and beta is showing as 12 degree. So this completes the solution. Hope you have understood and hope you have enjoyed this video. If yes, give this video a thumbs up. I request you to share with your friends. I will talk to you in the comment section. Do not forget to subscribe this channel. Thank you. Have a nice time. Bye.